What if I told you that some of the most influential people in history carried DNA that wasn't entirely human? In 2010, scientists made a discovery that shattered everything we thought we knew about our species. They found that millions of people walking among us today carry genetic material from creatures that went extinct 40,000 years ago. These weren't just distant relatives. They were different species entirely. And the most shocking part? Some individuals had so much of this other DNA that calling them fully human becomes questionable. Today, we're uncovering the hidden truth about the hybrids living among us, and why this discovery is rewriting human history itself. In a sterile laboratory in Leipzig, Germany, Dr. Svante Pääbo held a piece of bone that would destroy everything we thought we knew about being human. The year was 2010, and this Swedish geneticist had just accomplished what many considered impossible. He had successfully sequenced the genome of a Neanderthal who died 40,000 years ago. But what happened next would send shockwaves through the scientific community and beyond. As Pääbo's team compared this ancient DNA to modern human genomes, they made a discovery so profound that it literally rewrote the story of our species. The data showed something that contradicted decades of scientific consensus. Modern humans weren't pure. We weren't the single unified species that had conquered the world through superior intelligence and adaptability. We were hybrids. The numbers were staggering. Every person of non-African descent carried between 1 to 4% Neanderthal DNA in their cells. That might not sound like much, but consider this: humans and chimpanzees, our closest living relatives, differ by only about 1.2% in their DNA. So when we're talking about 2 to 4% foreign genetic material, we're talking about something that fundamentally changes what it means to be human. The revelation hit like a tsunami through academic circles. Textbooks needed to be rewritten. Museum exhibits had to be redesigned. The clean, linear progression of human evolution that we'd been teaching for generations was revealed to be a lie. But perhaps most unsettling of all was the realization that if you walked down any street in Europe, Asia, or the Americas, you were surrounded by people who weren't technically 100% Homo sapiens. For decades before this discovery, there had been whispers in the scientific community. Archaeologists would find bones that didn't quite fit the standard human model, fossils with features that seemed to blend characteristics of different species. But these anomalies were often dismissed, explained away, or simply ignored because they didn't fit the accepted narrative. The truth is, there was a kind of scientific orthodoxy that insisted modern humans had completely replaced all other human species without interbreeding. It was called the Out of Africa model, and it painted a picture of Homo sapiens as the ultimate evolutionary success story, a species so superior that it completely outcompeted and replaced every other human variant on the planet. But the genetic evidence was undeniable. As more ancient DNA was recovered and analyzed, the picture became even more complex. It wasn't just Neanderthals. In 2010, the same year as the Neanderthal genome announcement, scientists discovered evidence of another extinct human species that had contributed to modern human DNA, the Denisovans. These mysterious people, known primarily from a few fragments of bone and teeth found in a Siberian cave, had left their genetic signature in populations across Asia and Oceania. Some Papua New Guineans carried as much as 6% Denisovan DNA. Think about that. Nearly 1 in 20 of their genes came from a completely different human species. The scientific establishment found itself in an uncomfortable position. How do you tell the world that everything they learned about human evolution in school was fundamentally wrong? How do you explain that the very concept of being fully human might be more complicated than anyone imagined? The implications went far beyond academic curiosity. They touched on questions of identity, race, and what makes us uniquely human. As word of these discoveries began to leak out of academic journals and into mainstream consciousness, scientists realized they had unleashed something they couldn't control. The genetic data wasn't just revealing our past. It was exposing uncomfortable truths about our present. The distribution of ancient DNA wasn't random. Different populations carried different amounts and types of archaic genetic material. This created a biological map of human ancestry that didn't align with traditional racial categories or national boundaries. Some individuals of European descent carried significant Neanderthal DNA that affected everything from their immune systems to their brain structure. Certain Asian populations had Denisovan genes that helped them survive at high altitudes. African populations, while carrying less archaic DNA overall, showed evidence of interbreeding with yet other unknown human species. But perhaps most disturbing was what this meant for individuals with exceptionally high percentages of archaic DNA. If the average person of European descent carries 2% Neanderthal DNA, what about those who carry 4, 5, or even 6%? At what point does someone stop being Homo sapiens and start being something else entirely? The technology was advancing rapidly. By 2015, direct-to-consumer genetic testing companies began offering Neanderthal ancestry reports to their customers. Suddenly, ordinary people could log into a website and discover that they carried genes from extinct human species. Some found it fascinating. Others found it deeply unsettling. A few found percentages so high that they began to question their own humanity. Scientists tried to downplay the implications, insisting that all modern humans should still be considered the same species, regardless of their archaic DNA content. But the genetic evidence told a different story. These weren't just minor variations. They were fundamental differences that affected physiology, disease resistance, cognitive function, and even behavior. The discovery that shattered human history in 2010 was just the beginning. As we developed better tools for reading ancient DNA and understanding its effects, we began to realize that the question wasn't just whether some humans carried genes from extinct species. It was how much of this other DNA was enough to make someone no longer fully human. Sarah Chen thought she was getting a simple ancestry test for Christmas. The 34-year-old software engineer from Vancouver had always been curious about her mixed European and East Asian heritage. So when her sister gifted her a DNA kit, she eagerly sent in her saliva sample expecting to learn about her family's migration patterns. What she discovered instead changed everything. The results showed that Sarah carried 5.8% archaic human DNA, nearly 3 times the global average. Her Neanderthal percentage alone was 4.1%, putting her in the top 0.1% of all tested individuals. But even more shocking was her Denisovan ancestry, 1.7%, which was extraordinary for someone with her mixed background. When Sarah first saw these numbers, she laughed them off as a testing error. But additional tests from different companies confirmed the results. She began researching what this meant, and the deeper she dug, the more disturbed she became. Scientific papers described people with her level of archaic DNA as having measurably different brain structures, altered immune responses, and even variations in pain sensitivity. Sarah started noticing things about herself she'd never paid attention to before. Her unusually high tolerance for cold temperatures, the way she rarely got sick, even during flu seasons that devastated her coworkers. Her ability to function on remarkably little sleep. Her distinctive facial features that family members had always attributed to her mixed ancestry, but which now seemed to align with reconstructions of Neanderthal and Denisovan characteristics. The most unsettling realization came when she compared her results to her family members. Her parents each carried roughly average amounts of archaic DNA, but through some genetic lottery, Sarah had inherited far more than her fair share. Her sister's test showed only 1.8% archaic DNA, still above average, but nowhere near Sarah's levels. This raised a terrifying question. If genetic variation within a single family could be so extreme, how many people were walking around with archaic DNA percentages high enough to classify them as something other than standard Homo sapiens? And more importantly, how would society react if this information became widely known? Sarah's story isn't unique. As direct-to-consumer genetic testing became more popular, a quiet community began forming online. People who had discovered they carried exceptionally high percentages of archaic human DNA. They called themselves the hybrids, and they gathered in private forums to share their experiences and findings. Marcus Rodriguez, a 42-year-old archaeologist from New Mexico, carries 6.2% archaic DNA, one of the highest confirmed percentages on record. His combination includes 4.8% Neanderthal and 1.4% from an unidentified archaic species that geneticists believe may have been a previously unknown human variant. Marcus describes experiencing what he calls genetic memories, vivid dreams of Ice Age landscapes, and an inexplicable knowledge of stone tool techniques he was never taught. Then there's Elena Petrov, a 28-year-old from Estonia, whose 5.9% Neanderthal DNA comes with some remarkable physical characteristics. She has bone density 40% higher than average, can see clearly in near darkness that would leave most people completely blind, and has a skull structure that more closely resembles Neanderthal reconstructions than modern human norms. When she submitted to academic testing, researchers found that her brain showed activation patterns in regions associated with spatial reasoning and pattern recognition that were significantly different from typical modern humans. These individuals represent the extreme end of a spectrum, but they're not alone. Recent studies suggest that approximately 2 to 3% of the global population carries archaic DNA percentages above 4%, high enough to potentially affect their physiology and cognitive function in measurable ways. In raw numbers, that means somewhere between 150 to 200 million people worldwide could be classified as genetic hybrids rather than pure Homo sapiens. The hybrid community has developed its own informal classification system based on archaic DNA percentages. Those with 3–4% are considered low-grade hybrids. People carrying 4–5% are moderate hybrids. Anyone above 5% earns the designation high-grade hybrid, while the rare individuals approaching 7% or higher are sometimes referred to as neo-archaics, people who may have more in common genetically with extinct human species than with modern ones. The effects of carrying significant archaic DNA aren't just academic curiosities. They manifest in real, observable ways that affect how these individuals experience the world. Dr. Joshua Klein, a geneticist at Stanford University, who has been studying high archaic individuals, describes the phenomenon as living archaeology. Take bone structure, for example. People with high Neanderthal percentages often display characteristic skeletal features: broader rib cages, more robust limb bones, enlarged nasal cavities, and pronounced brow ridges. Sarah Chen's recent medical scans revealed that her bone density is 35% higher than average, and her lung capacity exceeds normal ranges by nearly 20%, traits that would have been advantageous for survival in Ice Age Europe. But the differences go deeper than physical structure. Neurological studies of high archaic individuals have revealed fascinating variations in brain function. Many show enhanced performance in tasks requiring spatial reasoning, pattern recognition, and working memory. Some display altered pain perception, requiring higher doses of anesthesia during medical procedures. Others report synesthetic experiences, seeing sounds or tasting colors, at rates significantly higher than the general population. The immune system effects are perhaps most dramatic. People with substantial Neanderthal DNA often carry ancient genetic variants that provide protection against specific diseases while creating vulnerabilities to others. Some show remarkable resistance to certain viral infections, but heightened sensitivity to autoimmune conditions. This creates a medical puzzle. How do you treat patients whose genetic makeup includes instructions written by evolution for a different world entirely? Perhaps most intriguingly, there's growing evidence that high levels of archaic DNA may affect reproductive compatibility. While all modern humans can technically interbreed, some studies suggest that genetic distance created by archaic DNA percentages may be leading to subtle fertility differences. Couples where one partner carries significantly more archaic DNA show slightly lower conception rates and higher rates of certain pregnancy complications. The hybrid community has begun tracking these patterns informally, and some members report feeling more compatible, both physically and emotionally, with other high archaic individuals. This has led to the emergence of what researchers cautiously term assortative mating. People unconsciously selecting partners with similar archaic DNA profiles. As our understanding of these genetic differences deepens, we are forced to confront an uncomfortable truth. The people walking among us with high percentages of archaic DNA are not just carrying ancient genes. They're living bridges to extinct human species. They represent a form of humanity that died out tens of thousands of years ago, yet continues to exist in diluted form within the bodies and minds of people alive today. 50,000 years ago, if you could somehow travel back in time and walk across the landscapes of Europe, Asia, and Africa, you would encounter something that would fundamentally challenge your understanding of what it means to be human. You wouldn't just find one type of human. You'd discover at least 5 distinct human species sharing the same planet, often competing for the same resources, and sometimes interbreeding in ways that would create the genetic complexity we see in modern populations. The Europe of 45,000 years ago was Neanderthal territory. These weren't the brutish cavemen of popular imagination, but sophisticated humans with brains actually larger than our own. They controlled fire, created complex tools, buried their dead with ceremonial objects, and even created art. Archaeological evidence from sites like Shanidar Cave in Iraq suggests they cared for disabled members of their communities and may have used medicinal plants to treat illness. Meanwhile, in the caves of Siberia and across much of Asia, the mysterious Denisovans had established their own civilization. We know frustratingly little about them because so few of their remains have been found, but their genetic legacy tells a story of remarkable adaptation. These people developed genetic mutations that allowed them to thrive at extreme altitudes, changes so beneficial that they persist in modern Tibetan and Sherpa populations today. In Africa, early Homo sapiens were emerging as a distinct species, but they weren't alone on their home continent. Evidence suggests at least 2 other archaic human species were sharing African territories, leaving genetic traces that scientists are only beginning to understand. Some researchers believe these ghost populations may have been the source of unique genetic variants found in modern African populations that can't be explained by standard human evolution. But perhaps most intriguingly, there's growing evidence of other human species we haven't even properly identified yet. Genetic analysis of modern populations reveals DNA signatures from at least 2 or 3 additional archaic human groups, dubbed Denisovan-related populations, by researchers who can detect their genetic influence, but haven't found their fossils. This wasn't a peaceful coexistence. Archaeological evidence paints a picture of intense competition, territorial conflicts, and survival struggles that would make modern warfare look civilized by comparison. The fossil record from this period tells a story written in violence. At Cima de los Huesos in Spain, researchers have found evidence of what appears to be systematic extermination. Dozens of early human skulls showing signs of intentional trauma, suggesting organized killing on a massive scale. Similar patterns appear at sites across Europe and Asia, indicating that conflict between human species wasn't occasional skirmishes, but sustained brutal warfare. The competition wasn't just about territory, it was about survival itself. During the harsh climate fluctuations of the Ice Age, resources were scarce, and different human species found themselves competing for the same caves, the same hunting grounds, and the same food sources. Archaeological evidence from sites like Mezmaiskaya Cave in Russia shows clear signs that different human species alternately occupied the same locations, sometimes displacing each other through violence. But the most disturbing evidence comes from sites that suggest cannibalism wasn't just practiced within species, it occurred between them. Bones from Neanderthal sites show cut marks consistent with deliberate butchering, and some bear the distinctive patterns of marrow extraction. Even more unsettling, some sites contain mixed remains suggesting that different human species may have hunted and consumed each other. The cave paintings at El Castillo in Spain, created around 40,000 years ago, may actually document these conflicts. Some researchers interpret certain abstract symbols and handprint patterns as territorial markers, or even warning signs left by one human species to ward off others. The art itself becomes a form of prehistoric psychological warfare. What makes this period even more complex is that while these species were fighting and killing each other, they were also occasionally interbreeding. Genetic evidence shows that the mixing wasn't rare. It was happening regularly enough to leave permanent traces in modern human DNA. This creates a paradoxical picture. Human species that were mortal enemies were also sometimes intimate partners. The hybridization wasn't always consensual. Some genetic patterns suggest what researchers euphemistically call asymmetric gene flow, meaning that most of the interbreeding involved males from one species and females from another, often indicating capture and forced breeding during conflicts. The genetic evidence shows that Neanderthal DNA in modern humans comes primarily through the female line, while Denisovan DNA shows a more balanced pattern, suggesting different interaction dynamics between these ancient populations. Around 40,000 years ago, something catastrophic happened. One by one, the other human species began disappearing. The Neanderthals, who had survived ice ages and climate shifts for hundreds of thousands of years, vanished from the archaeological record. The Denisovans faded away. The mysterious African archaic populations left only genetic echoes. Only Homo sapiens remained. What caused this mass extinction of human species remains one of archaeology's greatest mysteries. Climate change played a role. The planet was experiencing dramatic temperature fluctuations that put enormous pressure on all human populations. But climate alone doesn't explain why only our ancestors survived, while other human species, some arguably better adapted to harsh conditions, went extinct. Some researchers propose the competition hypothesis, that Homo sapiens developed some crucial advantage, whether technological, social, or cognitive, that allowed them to outcompete other human species. Evidence for this includes the appearance of more sophisticated tools, art, and social organization in Homo sapiens sites around the time other species began declining. Others suggest a darker scenario: systematic extermination. The archaeological evidence of violence between human species, combined with the rapid disappearance of other groups, raises the possibility that our ancestors did not just outcompete other humans, they actively hunted them to extinction. Some sites show evidence of what appears to be organized campaigns against Neanderthal populations, with entire settlements seemingly wiped out simultaneously. But here's what makes this story even more complex. While these other human species went extinct, they didn't completely disappear. Through interbreeding, they left permanent genetic contributions in modern human populations. In a very real sense, Neanderthals, Denisovans, and other archaic humans are still alive today. Their genes persist in millions of people around the world. This creates an unsettling parallel to modern times. The same species that apparently drove others to extinction also preserved parts of them through hybridization. It's as if our ancestors were simultaneously committing genocide and practicing preservation, ensuring that while these other human species couldn't survive as distinct populations, their genetic legacy would continue within Homo sapiens. The people today who carry high percentages of archaic DNA aren't just carrying ancient genes, they're living repositories of extinct human species. In their cells lie the genetic memories of Neanderthals who painted caves, Denisovans who adapted to mountain heights, and other archaic humans whose stories we're only beginning to understand. They represent the last echo of a world where humanity was not singular but plural, a time when being human meant something very different than it does today. When Dr. Janet Kelso first analyzed the immune system genes inherited from Neanderthals, she discovered something that would revolutionize our understanding of human disease resistance. These were not just random genetic leftovers from an extinct species. They were precisely the genes modern humans needed to survive in a world full of deadly pathogens. The HLA genes, which control how our immune system recognizes threats, tell an extraordinary story. Modern humans who carry Neanderthal versions of these genes show remarkable resistance to certain viral infections, bacterial diseases, and parasites. It's as if our ancestors received a biological weapons cache from an extinct species, perfectly designed for the new environments they were encountering as they spread across the globe. Take the HLA-AZO2 variant, inherited from Neanderthals and found in high frequencies across European populations. People who carry this gene show enhanced resistance to hepatitis B, HIV, and several strains of influenza. During the 1918 flu pandemic that killed 50 million people worldwide, populations with higher frequencies of Neanderthal immune genes suffered significantly lower death rates. But the most remarkable example comes from the STAT2 gene. The Neanderthal version of this gene, found in modern Europeans and Asians, the Denisovan contribution is even more dramatic. High-altitude populations in Tibet carry a Denisovan gene called EPAS1 that allows them to thrive in oxygen conditions that would incapacitate most humans. This isn't just a minor advantage. It's the difference between life and death above 13,000 feet. Without this gene, sustained human habitation of the Tibetan Plateau would be virtually impossible. But these genetic gifts come with a cost. The same Neanderthal genes that provide disease resistance also increase the risk of autoimmune disorders, allergies, and certain neurological conditions. It's as if evolution made a trade-off: enhanced survival in ancient environments in exchange for new vulnerabilities in the modern world. People with high percentages of archaic DNA often find themselves caught between these competing evolutionary pressures, blessed with some incredible abilities while struggling with others. Perhaps the most fascinating gifts from extinct human species involve the brain itself. Recent neurological studies of people with high archaic DNA percentages have revealed cognitive advantages that seem almost supernatural by modern standards. The Neanderthal contribution to spatial reasoning is particularly striking. Brain imaging studies show that people with substantial Neanderthal DNA have enlarged visual cortex regions and enhanced parietal lobe activity. In practical terms, this translates to extraordinary abilities in three-dimensional thinking, navigation, and pattern recognition. Sarah Chen, the software engineer we met earlier, scored in the 99th percentile on spatial reasoning tests and can mentally rotate complex three-dimensional objects with an accuracy that astounds researchers. Even more remarkable are the working memory advantages. The Neanderthal brain was actually larger than the modern human brain, and people who inherited significant portions of Neanderthal DNA often show enhanced short-term memory capacity. Marcus Rodriguez, the archaeologist with 6.2% archaic DNA, can hold and manipulate up to 12 distinct pieces of information in his working memory simultaneously, nearly double the normal human capacity of 7 items. But it's the Denisovan cognitive gifts that truly push the boundaries of what we consider normal human ability. Some people with substantial Denisovan ancestry show enhanced performance in what researchers call crystallized intelligence, the ability to access and use accumulated knowledge and experience. They seem to have an almost photographic memory for learned information and can make complex connections between seemingly unrelated concepts. Elena Petrov, the Estonian woman with 5.9% Neanderthal DNA, demonstrates another extraordinary ability: enhanced night vision. Her eyes contain genetic modifications inherited from Neanderthals that allow her to see clearly in light conditions that would leave most people functionally blind. She can navigate confidently in starlight and can detect movement and detail in near-total darkness. These cognitive advantages often come with enhanced sensory capabilities. Many high archaic individuals report heightened smell sensitivity, improved hearing acuity, and altered pain perception. Some describe experiencing synesthesia, seeing sounds as colors or tasting shapes, at rates significantly higher than the general population. Perhaps most intriguingly, there's growing evidence that archaic DNA may influence creativity and artistic ability. Neanderthals were accomplished artists who created cave paintings, carved figurines, and crafted sophisticated tools with aesthetic elements beyond mere functionality. People with substantial Neanderthal ancestry often show enhanced performance in artistic tasks, musical ability, and creative problem-solving. The physical advantages inherited from extinct human species read like a catalog of superhuman abilities. These are not minor improvements. They're fundamental enhancements that can mean the difference between survival and death in extreme conditions. Bone density is one of the most dramatic examples. People with high Neanderthal DNA percentages routinely show bone densities 30–40% higher than average. This isn't just about preventing fractures. It represents a fundamental difference in skeletal architecture. Their bones are literally built for a harsher world, capable of withstanding impacts and stresses that would shatter normal human bones. The muscular system shows similar enhancements. Neanderthals were incredibly robust, with muscle attachment points that indicate strength levels far exceeding modern humans. People who inherit substantial Neanderthal DNA often display unusual strength-to-weight ratios, enhanced grip strength, and resistance to muscle fatigue. Some can maintain physical exertion at levels that would exhaust typical humans within minutes. Temperature regulation is another remarkable gift. Both Neanderthal and Denisovan genes include variants that affect how the body responds to extreme temperatures. People with these genetic modifications often show extraordinary cold tolerance, able to function comfortably in conditions that would trigger hypothermia in others. Some report being comfortable in freezing temperatures while wearing minimal clothing, and their metabolic responses to cold stress are fundamentally different from normal human patterns. The cardiovascular advantages are equally impressive. High archaic individuals often have enlarged lung capacities, enhanced oxygen processing, and more efficient circulatory systems. These modifications, inherited from ancestors who lived in harsh ice age conditions, allow them to maintain physical performance in situations where oxygen is limited or physical demands are extreme. But perhaps the most remarkable physical gift is cellular-level damage resistance. Some archaic genetic variants appear to provide enhanced DNA repair mechanisms, improved cellular regeneration, and resistance to environmental toxins. People with these genes often show slower aging patterns, enhanced wound healing, and resistance to certain types of cancer. The combination of these physical and cognitive advantages creates individuals who are, in measurable ways, enhanced beyond normal human parameters. They represent living proof that the extinction of other human species wasn't a complete loss. Their genetic gifts continue to provide advantages in modern populations. However, these benefits come with modern costs. The same genes that provide cold resistance can cause heat intolerance in warm climates. Enhanced immune responses can trigger autoimmune reactions to modern foods and chemicals. The robust skeletal system adapted for Ice Age survival can cause joint problems when exposed to modern lifestyle patterns. As we continue to understand these genetic gifts from extinct species, we're forced to confront a remarkable reality. Some of the people walking among us today possess abilities that exceed normal human parameters, not through training or technology, but through genetic inheritance from human species that died out tens of thousands of years ago. They are living bridges to a time when humanity was more diverse, more specialized, and in many ways more capable of surviving in extreme conditions than we are today. In a secure facility outside Boston, Dr. George Church and his team at Harvard Medical School are conducting experiments that would have been considered science fiction just decades ago. They are not just studying ancient human DNA, they're actively working to bring it back to life. Using advanced CRISPR gene editing technology, Church's laboratory has successfully inserted Neanderthal genes into human stem cells, creating hybrid cell lines that express extinct human characteristics. These aren't complete Neanderthal recreations, but they're something unprecedented. Laboratory-grown human neurons that think with Neanderthal genetic programming. The implications are staggering. When these hybrid neurons are grown into brain organoids, miniature brain-like structures that can learn and respond to stimuli, they show distinctly different patterns of development and activity compared to standard human neurons. Some display enhanced connectivity in regions associated with spatial reasoning and pattern recognition. Others show altered neurotransmitter production that could explain the cognitive differences observed in people with high archaic DNA percentages. But Church's work goes beyond just understanding the past. His team is actively exploring whether Neanderthal genetic variants could be used to enhance modern humans. Certain Neanderthal genes provide resistance to specific diseases, enhanced physical capabilities, or improved cognitive function in particular areas. The question isn't whether we can reintroduce these traits, it's whether we should. The technology already exists to create what researchers cautiously call neo-Neanderthals, modern humans genetically modified to carry substantially higher percentages of archaic DNA. Early computer models suggest that someone with 15-20% Neanderthal DNA would have dramatically different physical and cognitive capabilities compared to typical humans. They might possess superhuman strength, enhanced disease resistance, and cognitive abilities that exceed normal human ranges in specific areas. Other research teams around the world are pursuing similar goals with different archaic human species. Scientists in China have successfully isolated and replicated Denisovan genetic variants associated with high-altitude adaptation, cold resistance, and enhanced immune function. Russian researchers are working on reconstructing the genomes of mysterious Siberian archaic humans whose DNA signatures appear in modern populations, but whose fossils have never been found. The race to resurrect extinct human capabilities has become an international competition, with profound implications for the future of our species. While scientists work to bring back extinct human traits in laboratories, something equally significant is happening naturally in modern populations. People with high percentages of archaic DNA are beginning to find each other, and they're forming communities that may represent the emergence of distinct human subspecies. The hybrid community that began as online forums has evolved into real-world networks. High archaic individuals are relocating to be near others with similar genetic profiles, forming what researchers call genetic clustering. Cities like Boulder, Colorado, and certain neighborhoods in Vancouver have become informal gathering places for people with substantial Neanderthal ancestry, drawn by both conscious choices and unconscious compatibility. Dating patterns within these communities show a striking trend. People with high archaic DNA percentages are increasingly choosing partners with similar genetic profiles. This isn't necessarily intentional. Many report feeling more comfortable and compatible with others who share their enhanced sensory capabilities, altered sleep patterns, or unusual physical characteristics. The genetic consequences of this assortative mating could be profound. Computer simulations suggest that if current trends continue, we could see the emergence of human populations with 8 to 10% archaic DNA within just a few generations. At those percentages, the differences between high archaic individuals and standard humans might become significant enough to constitute separate subspecies. Dr. Rebecca Martinez, who studies population genetics at UC Berkeley, describes this as reverse speciation, the process by which genetic variants that were diluted through thousands of years of mixing are becoming concentrated again through selective breeding patterns. Her models suggest that we could be witnessing the early stages of human speciation driven not by geographic isolation, but by genetic attraction. The implications extend beyond individual choice to societal structure. Some companies have begun quietly screening employees for genetic variants associated with specific capabilities. Certain tech companies seek out individuals with enhanced pattern recognition abilities, often correlated with Neanderthal ancestry. Military contractors have shown interest in people with superior night vision, enhanced strength, or exceptional spatial reasoning abilities. This genetic screening is creating what amounts to a biological caste system. People with beneficial archaic DNA variants find themselves with advantages in employment, education, and social opportunities. Those without these genetic gifts may find themselves increasingly marginalized in a society that values capabilities enhanced by extinct human DNA. As genetic modification technology advances and natural human populations continue to diverge based on archaic DNA content, society faces unprecedented ethical questions about the nature of humanity itself. At what point does someone with extensive archaic genetic modifications stop being Homo sapiens and become something else entirely? The question isn't merely academic. Insurance companies are already using genetic information to assess risk, and some policies specifically exclude coverage for complications related to non-standard human genetic variants. Educational institutions are grappling with whether to create separate programs for children with enhanced cognitive capabilities derived from archaic DNA. Sports organizations are debating whether people with Neanderthal-derived advantages in strength and bone density should compete against standard humans. Legal systems around the world are struggling to keep up with the genetic reality of modern populations. If someone with 8% archaic DNA commits a crime, should they be held to the same legal standards as someone with typical human genetics? Some archaic genetic variants affect impulse control, aggression levels, and decision-making processes in measurable ways. This has led to the emergence of genetic defense arguments in courtrooms, where lawyers argue that their clients' archaic ancestry contributed to their criminal behavior. the medical establishment faces its own ethical dilemmas. Should doctors have the right to genetically modify embryos to include beneficial archaic variants? Some parents are already demanding access to genetic enhancement procedures that would give their children Neanderthal-derived disease resistance or Denisovan high-altitude adaptations. Religious institutions have been forced to grapple with theological questions about the soul and divine creation when human genetics include DNA from extinct species. Some denominations have declared that people with high archaic DNA percentages are corrupted versions of humanity, while others embrace them as representing the full diversity of God's creation. Perhaps most troubling is the emergence of genetic supremacist movements. Some groups argue that people with high percentages of archaic DNA represent the next stage of human evolution and should have priority in resource allocation, breeding rights, and social leadership. Others advocate for genetic purification, the elimination of archaic variants from the human gene pool through selective breeding or genetic modification. International organizations are scrambling to develop frameworks for addressing these issues. The United Nations has established a commission on genetic human diversity, but reaching consensus on fundamental questions about human identity and rights has proven nearly impossible when the participants themselves represent genetically distinct populations. The technology to create more extreme genetic modifications is advancing rapidly. Within the next decade, it may be possible to create individuals with 20–30% archaic DNA. People who would be more genetically similar to extinct human species than to modern Homo sapiens. These neo-archaics would possess capabilities so far beyond normal human ranges that they might constitute an entirely new branch of humanity. Some researchers propose establishing genetic reserves, isolated communities where people with extremely high archaic DNA percentages could live and reproduce without interference from mainstream society. Others argue for integration policies that would prevent genetic segregation from creating permanent human subspecies. As we stand at this crossroads, we're forced to confront questions that go to the heart of what it means to be human. The discovery that some people carry significant DNA from extinct human species was just the beginning. Now, we must decide whether humanity's future lies in embracing this genetic diversity, controlling it through technology and policy, or watching it naturally separate us into distinct species once again. The people walking among us today who carry high percentages of archaic DNA aren't just genetic curiosities. They're harbingers of a future where the line between human and other becomes increasingly blurred. They represent both our connection to an ancient past, when multiple human species shared the Earth, and a possible future where humanity once again becomes not singular, but plural. The question is no longer whether some humans aren't fully human. It's whether humanity as we've known it will continue to exist at all, or whether we're witnessing the beginning of a new chapter in human evolution, where the extinct and the living merge into something unprecedented. The next time you're in a crowded place, a subway car, a coffee shop, a busy street, look around at the faces surrounding you. According to the genetic evidence we've explored, statistically several of the people you're seeing carry enough DNA from extinct human species that their classification as fully human becomes questionable. That person reading on their phone might carry Neanderthal genes that give them superhuman night vision. The woman waiting for her coffee could have Denisovan variants allowing her to function at altitudes that would incapacitate you. The man walking past might possess bone density and strength levels that exceed normal human ranges by 40% or more. We've discovered that the clean, simple story of human evolution we learned in school was a fiction. Humanity wasn't a single species that conquered the world through superior intelligence and cooperation. We were hybrid offspring of multiple human species, shaped by ancient interbreeding, competition, and extinction events that left permanent marks in our DNA. The implications reach far beyond academic curiosity. We're living through the early stages of a genetic revolution that's forcing us to redefine what it means to be human. As people with high archaic DNA percentages find each other and form communities, as genetic modification technology allows us to resurrect extinct human capabilities, and as natural selection continues to shape modern populations, we may be witnessing the beginning of human speciation. The ethical questions we face have no easy answers. How do we balance genetic enhancement with equality? What rights do genetically modified humans possess? At what point does someone stop being Homo sapiens and become something else entirely? But perhaps the most profound realization is that the extinction of Neanderthals, Denisovans, and other archaic human species 40,000 years ago wasn't the end of their story. They live on in the genes of millions of people today, providing disease resistance, enhanced physical capabilities, and cognitive advantages that continue to shape human survival and success. The hybrid humans walking among us represent living bridges to a more diverse human past and harbingers of an uncertain genetic future. They remind us that humanity has never been as simple or unified as we pretended, and they challenge us to expand our understanding of what it means to be human in an age where the boundaries between species, extinct and living, are becoming increasingly blurred. So here's what I want you to think about. Have you ever felt somehow different from the people around you? Maybe you've always had unusually good night vision, or you recover from illnesses faster than others, or you can visualize complex three-dimensional objects in ways that amaze your friends. Perhaps you've always felt more comfortable in cold weather, or you have that one friend who seems to possess almost superhuman strength despite their size. These aren't just individual quirks. They might be genetic echoes from extinct human species, still influencing how we experience the world today. The science is moving fast, and the implications are staggering. We're not just learning about our past, we're actively shaping our genetic future. Whether that leads to enhanced human capabilities, dangerous genetic segregation, or the emergence of new human subspecies, depends partly on how aware we become of these changes happening around us. If this topic fascinated you as much as it did me, I'd love to hear your thoughts. Have you ever had your DNA tested? Were you surprised by what you found? Do you think genetic modification to enhance human capabilities is ethical, or are we playing with fire? Drop your thoughts in the comments below. This conversation is just getting started, and I have a feeling we're going to be talking about these questions a lot more in the years to come. And if you want to stay ahead of the curve on discoveries that are rewriting human history, make sure to subscribe. Trust me, the rabbit hole of human genetic diversity goes much deeper than what we covered today, and some of the upcoming research results are going to blow your mind. Thanks for joining me on this journey into the hidden genetic reality of modern humanity. See you in the next one.